This is the finite element analysis of heat transfer in fins for rectangular annular number 5 by Gina Duff and Ian May. To find the optimal length for each material, we used the equation in the left box and set it equal to 0. We used an inner radius of 10 meters and an outer radius of 15 meters for our design. The perimeter and cross-sectional area for a fin with rectangular annulus are 2 pi r and 2 pi rt respectively. We performed 3 calculations on Wolfram alpha, changing the K value for each material. To find the heat loss, we used the equation in the right box. Theta B is the difference between the base temperature and the ambient air temperature. Here are the graphs from Wolfram alpha for each material. We approximated that an optimal length for copper would be 7 meters, an optimal length for aluminum would be 6 meters, and an optimal length for stainless steel would be 2 meters. This table shows the calculated heat loss for each material. As you can see, the approximated length is directly proportional to the thermal conductivity coefficient. We decided to use 5 meters for our fin length because it is long enough to accommodate copper and aluminum, but still short enough for steel. This way, users can switch between materials without changing fin design.
As you can see in this clip, the heat flux engulfs all of the copper fin at the length of 5 meters, which makes sense since our length should have been about 7 meters. Our minimum heat flux was found to be 0.358 watts per meter squared, and the maximum heat flux was found to be just under 5,000 watts per meter squared. The minimum temperature for copper was 21 degrees Celsius and the maximum temperature was 150 degrees Celsius. Similarly to the copper, the heat flux for aluminum appears to nearly engulf the entire fin again, which makes sense once again since our length was calculated to be about 6 meters for that material. The minimum heat flux was 1.05 watts per meter squared, and the maximum was found to be 13,193 watts per meter squared. The minimum temperature was found to be 36.5 degrees Celsius, and the maximum temperature was found to be 150 degrees Celsius. For stainless steel, the fin appears to have excess length looking at the heat flux. The minimum heat flux was nearly 0 watts per meter squared, and the maximum heat flux was 1,542 watts per meter squared. The minimum temperature was 15 degrees, and the maximum one is once again 150 degrees Celsius.